In this video, I'm just going to be demonstrating how to walk through a few example problems. It's definitely not going to be as cut together or good looking as some of our other videos in this class, but hopefully it'll give you an idea of how I would approach some of these problems and maybe do some of the homework. Now this is my RStudio. Yours I know may not look like this, but find the little area with the little arrow looking key thing and the blinking cursor, and then go on and copy and paste in that code from your Blackboard site. Notice a couple things sometimes students miss is they don't get the source piece and they don't get that last quotation mark or parenthesis. So make sure you got the whole thing and then press enter. Now I already ran this, so mine's going to go pretty quick. If you haven't already run that, it might take a little bit more time for yours to run, and that's okay. That's okay. So I went ahead and pulled up the homework app. This is what I've got. So for chapter 2, which is the chapter that I'm in right now, I got categorical or continuous. I'm going to start with a continuous example, then I'll move to a categorical example. So I'm working on problem number 520. You know what? Actually, I'm going to work on problem 314. So I'm going to work on problem 314. If you want to work on the same problem with me, you can copy and paste that in, or just type in, go to problem 314 on your own. Now on my Blackboard, I'm going to go on and write down these numbers so that I don't lose them and I can work with this data set. So 72, 77, 72, 62, 68, 63, 62, 74, 91, 62, 82, 92, 60, oh man, I just ran out of room, 97, and 71. So this is my data set that I'm going to be working with. So I've got it all jotted down in my terrible, terrible handwriting. And what I want to work on is I just kind of want to practice through everything. Now in class we talked about calculating the lower class limits, the class bounds of the different classes. We talked about making histograms. We talked about doing frequencies and relative frequencies and cumulative frequencies. So I'm just going to try doing all of that as I can. So one thing that's really useful when I'm working through actual problems is to write the data in order. Now sometimes this is kind of annoying to do, but again, it can be really useful. So I'm going to try doing that real quick, and it's going to take me a second. So I'm going to kind of pause and skip ahead so you guys don't have to watch this. But go on and try writing your data in order. Pause the video and write it in order, and then you can catch up with me when I jump ahead. All right, so I have the data written in order. Now when you're using the homework application, there's a couple of different ways that you can use it. You can either just work through everything and then go back and check your answer, or you can check while you're working. I tend to like to check while I'm working just to make sure I don't do too much work when actually I was wrong, because that kind of sucks. So maybe what I'll do is I'll go on and click over to my homework app and look at the ordered data and make sure the ordered data matches what I have: 60, 62, 62, 62, 63, etc. So you can pause this and look at this and make sure it matches. And I think it does match what I have in here. So now I have to think about what I want to use for a class width. And again, sometimes, or excuse me, first a class number of classes, because that's needed to calculate the class width. Now on the homework application, if we go to this, you can actually, I'll hide my answers because I don't want to see, you can actually click and drag the number of classes that you want to use, anywhere between 5, 7, and 10. Excuse me, 5 and 10. I'm going to use 6 just for fun. It's one that I don't normally use, but I'll use number of classes equals 6 just for fun. All right, now for our class width, we're going to have the calculation of the max minus the minimum divided by the number of classes. Awesome. So the maximum number is going to be 60, or excuse me, the minimum number is going to be 60. The maximum number is going to be 97. So I'm going to do 97 minus 60 divided by 2, and I'm going to pull up R to do that because I'm super lazy. Oh, excuse me, not divided by 2, divided by the class width, or excuse me, the number of classes divided by 6. So let's see, 97 minus 60 is 37, divided by 6, looks like 6.16 repeating, and recall that we always round up, so the class width is 7. And this is a great example of how 6.16 we normally wouldn't round up, but when we're doing the class width we always round up, so 7 is going to be our class width. Now we're doing 6 classes, so I'm going to go on and I'm going to start my lower class limit. And I tell you what, I'm going to go on and do lower class limit and the upper class limit, and then I'm going to practice doing my lower class bound and the upper class bound. So I'm just going to try doing a little bit of everything just to get practice in, because I just want to practice and make sure I know how to do all these things. So I'll start by erasing these class bounds. We'll focus on the class limits for now. So the lower class limit and upper class limit. And actually, eventually I'm going to make a big old table, so I'll put these pretty close together. So for my lower class limit, I start at my minimum value, and again, I almost always start at the minimum, 60. And then I add the class width to get to the next one. So my class width right now is 7, so I add 7 to get to 67. For my next lower class limit, and then do it again, 67 plus 7, that gives me 74, and 74 plus 7 gives me 81. Now I have to think about how many classes I'm doing. I'm doing 6 classes, so this is first class, second class, third class, fourth class. So the fifth class, I do it a couple more times. 81 plus 7 is 88. 88 plus 7 is 95. So this is the fifth class, the sixth class, and I'm only doing 6, so I stop here. All right, now for the lower class limit, recall that I subtract 1 from the second, for the upper class limit of the first class, I subtract 1 from the lower class limit of the second class. So I start with 67 minus 1, so my upper class limit's 66, and then I add 7 again. So 66 plus the class width, that gives me 73. 73 plus the class width gives me 80. 80 plus the class width gives me 87, and so on. 87 plus 7 is 94. 94 plus 7 is 101. So this is a good spot to stop and double check my work. So I'm working on the class limits. And so 60 to 66, yeah, that's right. 67 to 73, yeah, that's right. And then all the way to 95 to 101, yeah, that's right. Now I'm going to hide it before I look at anything else because I don't want to cheat and ruin my education. I just want to make sure I get that. Okay, now if I want to, I can work on calculating the frequency, and I guess I'll do this before I do some of the other stuff. So the frequency is just looking at how many numbers are in between 60 and 66. So I'm just going to try to count how many numbers are in between 60 and 66. So looking at this, 60, 62, remember we include 60. We include the edges of the class limit. 62, 62, 63, 63. And actually, when they're all lined up like this, it's really easy to see, oh yeah, these 5 numbers are in between 60 and 66. Now we're looking between 67 and 73, so there's kind of a break there. 67, okay, 68 counts, 71, 72, 72, and then that's where the stop. So these 4 numbers are in between 67 and 73, so 4. Now between 74 and 80, 74, 77, so there's only 2 numbers between 74 and 80. 81 and 87, there's only one number between 81 and 87, that 82. Oh, that's kind of interesting. I randomly generate all these in the homework app, so I literally don't know what they are. 91 and 92. So there's two numbers between 88 and 94. And there is just one number, 97, on the top end between 95 and 100. Now I'm going to go and double check this frequency. So I've got 5, 4, let's see, 5, 4, 2, 1, 2, and 1 that I'm going to double check in my homework app. So wherever the frequency column is, and I'm ignoring everything else, I just want to look at the frequency. 5, 4, 2, 1, 2, 1. Hey, I'm doing it. Not bad. Okay. So what are some other things that we did? Well, we did cumulative frequency. So that came, oh no, next we did relative frequency. So in relative frequency, okay, this one I'm definitely going to need a calculator, so I'm going to get my calculator out here. So in relative frequency, we took each of these and divided by how many numbers total. Now to find the numbers total, remember you can, well, remember, I'm not sure if we talked about this or not, but you can just add up how many values are in the frequency column, because this is all of the different data that you have. So if you just add all of these up, that's the total amount of that's the total number of numbers that you have. That's the sample size n. So 5 plus 4 plus 2 plus 1 plus 2 plus 1. I'm just going to type that into my calculator. 1 plus 2 plus 1, that gives me 15. N equals 15. So my relative frequency, I'm literally just going to take each of these values and divide by 15. Now on a test, you do not have to write these out. So 1 divided by 15, 2 divided by 15, 1 divided by 15. You don't have to write all these numbers out, though sometimes, like if it's a multiple choice answer, it may come in decimal form. So you may have to know that 5 divided by 15 is 33%, or 4 divided by 15 is, I don't know, I'm going to type it in my calculator, 0.266 repeating. So these are relative frequencies. And I can go double check this on my homework app just to make sure I'm not crazy. So in the homework app, rel freaks is relative frequencies, and you see 5 over 15, 4 over 15, 2 over 15, etc. So hey, all those work out. Looks like I got it. All right, now for a cumulative frequency. So remember, cumulative frequency is whatever category I'm interested in plus all the rest on top. So whatever category plus everything else on top. So starting in the first one, my frequency is 5 because there's nothing on top. But in the second one, it's my second frequency, number 4, plus everything else on top. So it's going to be 4 plus 5, or 9. In the third one, it's going to be the 2 plus everything else on top. So it's going to be 2 plus 4 plus 5, or 11. One quick trick that you can use is this 11 is the sum of everything on top. So instead of having to do 1 plus 2 plus 4 plus 5, I already did 2 plus 4 plus 5. That's 11. So I can just do 1 plus 11 to get 12, or 2 plus 12 to get 14. So whichever way works best for you. Actually, a good double check of cumulative frequency is that the last number in the cumulative frequency should be your sample size. So I'll go to my homework application and check my cumulative frequency. Again, I'm ignoring everything else because I don't want to cheat, but there's cumulative frequency. It says 5, 9, 11, 12, 14, 15. Hey, fantastic. My cumulative frequency looks right. We also had the midpoints. That was a thing. So midpoint, now remember the midpoint was just the average. So I've got my class limits written out right now. Upper class limit plus the lower class limit divided by 2. So in this case, this is going to be 60 plus 66 divided by 2. 60 plus 66 is 126. And 126 divided by 2 on my calculator is 63. And then I can do the same thing next. 67 plus 73 divided by 2, and I'll just type that. 67 plus 73 on my calculator is 140 divided by 2 is 70. Now there's a shortcut so that you don't have to do this the whole time. And the shortcut is just like we did on the left side when we were dealing with our class limits. We went from the upper class limit and we added the class width to get to the next one. With the midpoint, you can also add the class width. So remember, our class width was 7. So in the midpoint, we can also take this 63, add the class width, and get 70. Yeah, 63 plus 7, 70. So a shortcut, if you don't want to redo this math every time. Now don't get me wrong, you can redo this every time and you'll get the correct midpoints every time. But if you want a shortcut, you can just find the first midpoint and then add the class width to get the rest of them. So 63 plus 7 gets 70. 70 plus the class width is 77. 77 plus the class width is 84. 84 plus the class width is 91. And 91 plus the class width is 98. So I'm going to go and double check my midpoints here. Midpoint 63, 70, 74, or 77, 84, 91, and 98. Hey, that's not too bad. Very cool. All right, the last thing that I'll do is I'll practice my lower class bounds and my upper class bounds. And this will give me everything that I need to start writing out a whole bunch of plots so that I can practice my plotting too. So my lower class bound, I start with the smallest value. So I start with this 60 number that I was using earlier. And then I subtract 0.5. So 60 minus 0.5 is 59.5. And then I add the class width to get the upper class bound. So the class width is 7. So 59.5 plus 7 is 66.5. And then we said that the upper class bound is the exact same thing as the next class's lower class bound. So these two numbers are the same. The upper class bound and the next lower class bound, these guys are exactly the same. And then again, I add the class width to get the next upper class bound, so 66.5. I'm just going to type this into my calculator. Plus 7 is 73.5. Then I add that. That's the same thing as the next class's lower class bound. And then I add 7 again to get 80.5. And that's the same thing as the next lower class bound. Add 7 again to get 87.5. And so on. 94.5 as the starting place. And then add 7 again to get 101.5. And recall how we discussed, you can double check this. The lower class bound is 0.5 lower than the lower class limit, and the upper class bound is 0.5 higher than the upper class limit. So very rarely, honestly, when you're doing this for a test, will you have both the lower class limits and the lower class bounds. But if you do have them, you can quickly double check. So for instance, in my fourth class, the lower class limit is 81, and yes, my lower class bound is 80.5. The upper class limit's 87, and yes, the upper class bound is 87.5, so it looks good. All right, so with this information, I'm going to quickly draw out a few graphs. So maybe for fun, I'm not going to draw out all the possible graphs that I can, but maybe I'll try drawing a, let's try for fun doing a cumulative histogram. No. Let's just do ones that we would actually get. So on an exam, what I would actually give you is a histogram, a relative frequency histogram, a frequency polygon, a relative frequency polygon, or an ogive for continuous data. So we'll just do, let's do a histogram, and tell you what, let's do an ogive because I don't think we've done an ogive yet. So For the histogram, I'm going to go on and draw out my data. Now, let's see. So for a regular old histogram, my y-axis is going to be labeled frequency. My x-axis depends on the data. So with this data, I'm assuming this data is diastolic blood pressure. And I know it doesn't say it in the homework app, but just visualize to yourself whatever this variable name is so that you can get practice thinking about it. Now for my frequencies, I've got frequencies that range between 5 and 1. So I don't need too many dashes. I just need, I'll just go by ones. 1, 2, 3, 4, 5. And then for my x-axis, I'm going to put a little squiggle because I'm not going to start at 0. I'm going to start at, remember when I'm drawing my histogram, I do not use my lower class bounds or lower class and upper class limits. I don't use those. I want to use my lower class bounds and upper class bounds. So don't get confused. When I'm drawing my histogram, I'm using the class bounds. So I start at 59.5. And then we have 66.5. Guess we can give it a little more range than that. And then 73.5, 80.5, and so on. .5. There we go. Okay, and then I just draw my bars up to the appropriate height. So for this first one, the appropriate height is going to be 5. So I go up 1, 2, 3, 4, 5. For the next bar, remember it's connecting because this is continuous data and I'm reflecting that. It's going to go up to 4 and it's going to stay connected. The next bar is going to go up to 2 and it's going to stay connected. The next bar is going to go up to 1 and it's going to stay connected. Then 2 and then 1. And this is my regular old histogram for my diastolic blood pressure. Typically in class you're graded on 5 things. You're graded on your x-axis label, you're graded on your y-axis label, you're graded on your y-axis units, you're graded on your x-axis units, and you're graded on the shape of the plot. Did you draw a histogram? Did you draw a frequency polygon, etc.? All right, so for the next one, let's do an ogive. So for an ogive, recall the definition of an ogive is just the cumulative frequency polygon. So that's all our ogive is. So I'm going to keep the label diastolic blood pressure. But now, because I'm doing a frequency polygon, instead of graphing with my class bounds, I'm going to be graphing with my midpoints on my x-axis. So I'm going to go on and draw my midpoints, 63, 70, 77, etc. And to keep me from going up, I'm just adding the class width, 77. 7 is 84, 84 plus 7 is 91, 91 plus 7 is 98, and where do I end? 98 is the last one. Okay. And then on my cumulative frequency, now in my regular frequency, remember I just had a height from 1 to 5, but in my cumulative frequency, now I'm starting at 5 and going all the way up to 15. So again, I'm going to keep my axis at 0 just so that I can stay centered at 0 and I don't have to worry about my units shifting. But now I'm going to go up to 15. So let's do 5, 10, 15, and actually maybe I'll try to do by ones. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 4, 5. Okay, so this is 5, 10, and 15. That's the best I got. Not a very straight y-axis, but what do you do? All right, and then for my midpoint, I start at my midpoint and I just go up however high I need to go up for that particular value. So here I'm going to start, my first midpoint is 63 and my cumulative frequency is 5, so I'm going to start at 63 and go up 5. Then I'm going to go to 70 and go up by 9 and so on. So 63 goes up to 5 and I make a dot. Again, 70 goes up to 9 and I make a dot. And so on. 77 goes up to 11, then 12, 14, and 15. So 11 going up to 11, it's about right there. 11, 12 is just a little higher, and 14, and then 15, something like that. And then remember, the last step of the frequency polygon is to connect all of your dots with the line. So I know that this is an ogive, but remember, an ogive is a frequency polygon. It's just a frequency polygon for your cumulative frequency data. So we're making our ogive here, and that's our ogive. It's our cumulative frequency polygon. That's just a definitional thing. So this has been a quick video on how to go through the homework app and do some homework app problems. I might do one more of these videos going through some of the categorical problem instead of a continuous problem. But again, how I would use this homework app is I would focus on just getting practice with a data set, jumping in. So this took about maybe half an hour to do all of my practice tables, and then a bunch of graphics. I did histogram, I did an ogive, and actually once the table's constructed, the graphics go pretty quickly. So real quick, maybe one last thing we can do before we sign off here is go and double check my histogram and my ogive on the homework app. So I'm going to go to solutions and I'm going to scroll down. Here's my frequency histogram, and this looks correct. My frequency histogram looks right. Have the height of 5, 4, 2, 1, and 2. Note that it's not going to be exactly the same, but I can check my x-axis, make sure all my x-axis labels are correct, make sure all my heights are correct. There's frequency polygon, relative frequency polygon, and then here's my ogive. Now the ogive looks a little weird. I might click and drag my screen a little bit to resize it because my plot was a little bit thinner. Oh yeah, that looks a little bit closer to what mine looked like. Again, I'm checking my x-axis tick marks, my y-axis tick marks. This goes by 5s. I did 5s and then little 1s, but that's okay. Again, the tick marks on the y-axis don't have to match. The tick marks on the x-axis should match exactly. So we'd look on the x-axis tick marks and make sure that 63, 70, 77, 84, 91, and 98 are on there. And then that the heights are about the same and that the shape looks about the same, and it does. It kind of makes a little arc and then it jumps back up and makes another little arc, which is kind of what mine does. So in the next video, again, we'll try jumping in with one of these categorical data analysis problems.